In this video, we solve quadratic equations using a technique known as extracting square roots. What do we mean by a quadratic equation? A quadratic equation in one variable x is an equation that can be written in the form ax squared plus bx plus c equals 0, where a, b, and c are fixed real numbers, and a is non-zero. There are 4 algebraic methods for solving quadratic equations in one variable. The most basic method is called factoring and was discussed in a previous video. The second method is called extracting square roots and will be the primary focus of this video. Extracting square roots is essentially a shortcut for factoring the difference of squares. The third technique is a process called completing the square, and the fourth method is using the quadratic formula. Let's first consider a review example in which we use the factoring method. Solve x squared equal 25. This is a quadratic equation that is not in standard form. We put it in standard form by subtracting 25 from both sides, resulting in a difference of squares. We factor x squared minus 25 as the product of the quantity x minus 5 times the quantity x plus 5, and we have a product equaling 0. We set each factor equal to 0 and solve the resulting equations to get x equal 5 or x equal negative 5. Let's reconsider the same problem to introduce extracting square roots. We notice that in x squared equal 25, we have a perfect square on both sides of the equation. We could take the principal square root of both sides of the equation. Note that one important feature of a function is that a function applied to equal inputs produces equal outputs. The primary reason we defined the principal square root in general was to produce a function. Now, as we've seen repeatedly, the square root of x squared is absolute value of x, and the square root of 25 is 5. Then to solve the resulting absolute value equation, we get x equals plus or minus 5. Therefore, the solution is x equal 5 or x equal negative 5. Now that we've seen a preliminary example utilizing the extraction of square roots, let's summarize the details of the technique. There are 2 important facts that are used in the process. First, for any x, the square root of x squared is absolute value x. And second, for positive a, absolute x equal a means that x equals plus or minus a. Now let's consider examples in which this technique is useful and factoring is not an obvious choice. To solve the equation x squared equals 7, we first note that we have a quadratic equation with no x term. We take the principal square root of both sides, and this produces absolute value of x equals the square root of 7. So x equals plus or minus root 7. The solution is x equals root 7 or x equals negative root 7. Notice that in this example, factoring the difference of 2 squares might not have been an easy thing to do. Let's proceed with increasingly complicated examples. Let's solve the equation quantity x minus 1 squared equals 7. This is a quadratic equation that looks very similar to our previous example. We can take the principal square root of both sides. The square root of a perfect square yields an absolute value. Removing the absolute value produces a plus or minus. This actually gives 2 equations, but we often keep them written together. Adding 1 to both sides produces the two solutions x equals 1 plus or minus root 7. We could not have found these solutions by factoring. Let's consider a final example to strengthen our understanding of this process. Solve the equation quantity x plus 3 squared equals 11. This is a quadratic equation that looks somewhat similar to our previous example. We take the principal square root of both sides of the equation. The square root of a perfect square yields an absolute value. Removing the absolute value produces the plus minus. This actually gives two equations, but we're going to keep them written together. Adding -3 to both sides of the equation produces two solutions, x equals -3 plus or minus the square root of 11. It is customary to write expressions involving radicals with other terms or factors in front of the radical to avoid ambiguity.